This is the top half of an S6A air compressor governor. It's just been freshly overhauled. And it's very typical. The Type J governors have the same electrical top end as to the S6B governors and some of the governor synchronizing switches. So it's a pretty common Westinghouse traction brake or Westinghouse air brake component. So an overhaul on the electrical portion, we're generally looking at the condition of the contacts, finger pressure. In this case we have to change them because the fingers are worn flat. Typically they get on inspection, they get a little bit of Vaseline on the actual fingers and contacts here. Then the other thing with these is, of course, cleanliness. This doesn't use a magnetic blowout, it uses an air blowout. So when the compressor cuts out, there's an air jet that comes up and extinguishes the arc. Obviously it's DC, 600 DC. They're good for about 15 amps at 600 volts DC. The other thing to watch is tightness of the finger screws there. And the gap here, somewhere between an 1/8 and 3/32, and that keeps it from stubbing. When it's in the cutout position, it comes down. If these sit down too far, it could actually get hung up on the end. So you normally set those about 1/8 of an inch to 3/32 of an inch, and then lock them down. Normally the wiring is done is open wiring from the bottom. It comes up and is held by set screws. It has a ferrule on each end of the wire. Compressors use number 12 AWG wire in all cases for up to about 15 amps. And that's really about it with these. Make sure the cotter pin's in, that the insulators are dead clean, and they're dielectric material, and they have to be dead clean. Everything needs to be kept clean on these, no oil. And with the valve portion, the body gaskets tend to compress and leak. They're leather, they tend to compress and leak with age, so they tend to need to be changed. The piston leather as well tends to compress and have to be changed with age. Sometimes you can just flip them over. New ones are available from C.W. Marsh in the U.S. And the same thing with the bottom end. There are a lot of holes and ports that can get clogged. They need to be really clean. And we'd overhaul these typically 2 to 3 years. The maximum we get out of them is about 3 years before rust powder and scale starts to get into them, clog them up. There's not much lubrication required other than these contacts. The piston ring gets a few drops of triple valve oil, and the same thing with the cut-in and cut-out valve, just a few drops, spread nice and evenly, not too much. And you overhaul them 2 or 3 years. They're pretty reliable. They're a little tricky to set up. This is the cut-out valve. That's the cut-in valve, and you have to find the range to cut out first. And then once you do that, you can adjust that and drop the air pressure until your cut-in clicks in, and then you start setting the ranges. Typically for a conventional street carrier, normally you can get 55 to 70 pounds, 55 cut in, 70 cut out. The later cars from the 20s and later 20s and 30s, they tended to go 65, 75 cut in and cut out. And of course interurban cars were typically 85 cut in to 100 cut out at that time. And that's about it. They're finicky, and they're a little finicky to set up. They're a little troublesome to set up, but once they work, you just leave them alone, and they'll last about 2 or 3 years. If they start to foul up, it's time for an overhaul. You can't really readjust them because it usually indicates there's dirt in the valves, and it's time to clean them. So about 2 to 3 years for museum-type operations.
Good.